Okay, here we go with the second part of 12-4, 12-4B. And yeah, this is a pretty short one. So let me share my screen with you guys. But we're going to get into some of the other similarity theorems. Okay, well, one thing I want to make sure we note is that that similarity is an equivalence relation. Remember equivalence relations, reflexive property, symmetric property, transitive property. And we saw how that worked for equality or equations, and we also saw how it worked for congruence. Well, same with similarity, right? If you have triangle ABC similar to triangle DEF and triangle DEF similar to GHI, what can you conclude? Yeah, that triangle ABC is similar to triangle GHI. Actually, put these on because I know that makes a lot of noise when I. All right, maybe this will be better. Okay, so the SAS similarity theorem, aka the SASS theorem. If two pairs of corresponding sides are proportional and the included angles are congruent, okay, notice the proportional being circled and included angles congruent underlined, then the triangles are similar. Okay, so you don't have to have the sides congruent, obviously, because if it was, we'd be proving congruence, not similarity. But if they're in proportion, and the included angle is congruent, then you're going to have similar triangles. And SSSS, otherwise known as that was different than that was says if three pairs of corresponding sides are proportional, then the triangles are similar. And my question to you is to think about and answer, is there just an SS corollary like we had just an AA corollary after learning the AAA similarity theorem? And why or why not? So think about that for a sec. If you're not sure, try drawing it out. Try drawing triangles that have two sides that are the same, same, they could even be congruent. It really doesn't matter. But think about how you could angle them differently, right? But, in order to have just an SS correlate, it means you just have to have two sides and that's it. Is that can always work? The answer is no. And here's a good example, right? So here's a situation where I think I try to draw these sides to be the same length and these sides to be the same length. Well, you can see that depending on what angle I have between those two sides, the third side's not going to be in the same proportion. If these were, 1-to-1, for example, in other words, they were the same, these clearly are not in a 1-to-1 ratio. Okay. All right, so let's do some practicing here. State whether the triangles are similar or not. Okay, if they are similar, then what theorems did you use? Okay, so take a look at that. Remember, similar triangles, what the requirements are. What do you think on this first one here? All right, I'm gonna uncover. So one way to set this up is 5/10 equal to 4/8, because one way to think about this is that you could have 5 corresponding to 10, right? 4 to 8, and 7 to 14, okay? May not look like that based on what's drawn, but by the numbers and by doing all 3 sets of sides, it works out, okay? All right, what about on this one, the AEIOU problem here? What do you think? Okay, I'm gonna uncover. This one you could do by SAS because you have vertical angles, right? So those angles are congruent. So there's our A. And is 8/10 the same proportion as 4/5? Sure is. Yeah. So that works. Okay. What in the world do I have down here? Oh, I'm just identifying what the triangles were. Yeah. Triangle AIE similar to triangle OIU. So you have to make sure you get those corresponding, right? The A corresponds with the O, the I corresponds with the I in this case, and the E with the U, okay? All right, moving along. This is what, there's a lot of things that we can get from this. So spend a little bit of time, see what you can prove to be similar here. Okay. Notice what figure this is, by the way. You got congruence there and you got parallel there. Okay, I'm gonna uncover now. So one thing that Mirabelle, who was my daughter's friend back in middle school, proved, and where does she go to school now? She goes to Princeton, I think. Triangle BDA is similar to triangle ACB, okay, by SASS, okay? So we have that one. Let's see how many of these you got. Did you get the ADC and BCD, right? These angles we know are congruent. We have a common side, and obviously the proportion here is going to be the same as this over itself, right? Okay. Or you could have done by SSS, right? Because what do we know about these in a isosceles trapezoid? What do we know? Right, diagonals are congruent. Okay, did you get ABE and CDE? Okay, could have done that by SASS or AA. Okay, how would we do that by AA? We got the verts, right? And what else do we have? Oh, we've got what? PAI is this angle and this angle. Oh, yes. Okay. And then also we could have proved BEC, and AED. Similar situation here, AA or SAS. Okay, and then looking down here at this bottom one, are these similar? We've got a right angle sign there. Try that one. Okay, I'm going to uncover. So does this work? Well, we know where they're going to have congruent angles, but does 4/8 have this? Is that the same proportion as 6/10, right? So this whole tall one is the 10. This is the corresponding one on the smaller one. So 6/10, does that equal 4/8? No. Okay. And that's it for 12.4b. Yeah, pretty short one. Have a good rest of your day or evening.